Variance captures how spread a distribution is, but it is expressed in squared units of the original variable. This makes direct interpretation difficult. We need a measure of dispersion that lives on the same scale as the data. Standard deviation is defined as the square root of variance. Taking the square root undoes the squaring of units. The result is a dispersion measure expressed in the original unit of the variable. Standard deviation measures the typical magnitude of deviations from the mean. It treats positive and negative deviations symmetrically. It summarizes the scale of the distribution, not its shape or direction. Standard deviation and variance contain the same information. One is the square of the other. The transformation between them is monotonic. Knowing one determines the other completely. Standard deviation is not a bound on outcomes. Large deviations beyond several sigmas remain possible. A small sigma describes the typical scale of fluctuations. It does not eliminate extreme outcomes. Standard deviation improves the interpretability of variance, but it inherits all of its limitations. It cannot distinguish distributions that share the same spread but differ in shape, asymmetry, or tail behavior.